Hello everyone, this is Dr. Amit Kumar Pandey. I am going to discuss today SRTF CPU scheduling algorithm, which is an important CPU scheduling algorithm in operating system. As in operating system, there are several processes or every process want to get execute itself. So there should be some policy or strategy to execute all the process in some specific manner. So we have number of policies or strategy in which one is SRTF CPU scheduling algorithm, which is preemptive version of SJF, shortest job first CPU scheduling algorithm. So in previous lecture, we covered shortest job first CPU scheduling algorithm. In this lecture, we will discuss SJF with preemption means SRTF, shortest remaining time first CPU scheduling algorithm. Let's see one by one what is pro and cons of this CPU scheduling algorithm and how it works. So basics of SRTF is that in SRTF scheduling, out of all the available processes, the process having the smallest burst time will get the CPU first, then second smallest, and at the end, the largest uh, process means the process which have largest CPU burst time. If arrival time of more than one process are same, then process with the smallest burst time will get the CPU, and arrival time and burst time both of more than one process are same, then the process with the smallest process ID will get executed first. Advantages of SRTF is like SRTF is optimal and guarantees the minimum average waiting time, and it provides a standard for other algorithms since no other algorithm performs better than the SRTF. What are the cons of SRTF CPU scheduling algorithm or disadvantage of SRTF CPU scheduling algorithm is it cannot be implemented practically since burst time of the processes cannot be known in advance, and it lead to starvation for processes with large burst time, and priorities cannot be set for all the processes, and process with larger burst time have poor response time means in this priority cannot be set for the processes. This is the main disadvantage. And the response time for larger processes means the process which have larger burst time is very poor. They can enlarge the response time. Okay, let us see this SRTF algorithms working with an example. So we take here number of processes. Okay, and their respective burst time and respective arrival time. Okay. So suppose there is a process P1 and another process P2 and another process P3 having the burst time for P1 this is 100, for P2 this is 50, for P3 this is somehow 60. Okay. And arrival time of P1 is 0 and P2 is 40 and for P3 this is 50. So how the SRTF will work? Let us see. First, we will make a Gantt chart to calculate individual waiting time or individual turnaround time. So here, the first process arrives at 0 time. So CPU start its execution at 0 time. So we start from 0. At the time of 0, the availability is of single process with P1. है ना? At 0 time, there will be a single process only, which is P1. So we processor will start execution of P1 and it will check the ready queue after a single time, after each single time to check whether there is another process which want to execute. So that we can compare that process with the current executed process and which have the least burst time in both. then we will fetch for that process for execution. So here we can see the second process arrives after 40 unit time. So we run it to 40 unit time. Even processor will check on every single unit interval time for another process, but as in numerical, the second process arrives on after 40 unit time. So we run the P1 for 40 unit time. So when P1 will get executed 40 unit time, the remaining bus time for P1 will be 60. Okay. And after 40 unit time, there is another process named P2, which want to execute also. So we compare the bus time of currently executing process P1 and the bus time of currently arrived process P2. Which one is shorter, 60 or 50? So 50 is shorter. So we preempt P1 and fetch P2 for execution. As we can see, the next arrival is on 50 unit time. So we run P2 for 10 unit time. Sorry, 10 unit time, it will be 50. And remaining bus time for P2 is 40 because we executed for 10 unit time. On 50, there is another process named P3. Now, in system, there are three processes. P1 with 60 unit bus time, P2 with 40 unit bus time, and P3 with 60 unit bus time. So, which one is shorter? Definitely P2 is shorter, so we run P2. There is no other process in the system, so we run uh, remaining bus time of P2 at P2 will get executed completely. So P2 remaining time for P2 is 40, so we run it 40 unit time. So total time will be 90 and P2 is terminated. Now P1 also have the 60 unit bus time and P3 also have the 60 unit bus time. So we will give preference to P1 because it already get executed its some part. So P1. P1, remaining bus time of P1 is 60, so this will be 150 and P1 will get executed and terminated. Now we run P3. P3 have bus time of 60, so it will be 210. Now all the process have executed. So asking it same, what is average waiting time and what will be the average turnaround time? So for AWT and ATAT, we have to calculate individual waiting time and individual turnaround time. So for individual waiting time, for P1, for P2, and for P3, we can see here in Gantt chart, for P1, this is 0, for P2, this is 40, and for P3, this is 150, I think. Is it correct? We can see here at time 0, P1 get the CPU and start this execution and run for 40 unit time. Then waiting time is 0 in this response. Again, we see P2 arrives meanwhile and P2 execute itself and P1 is preempted. So P1 get the CPU again after 90 unit time. Okay, na? Then execute itself completely. So 40 to 90, 40 to 90 is 50 unit time. P1 have to wait. Okay. For P2, we can see here the waiting time is 40 and P2 get executed in a while, not in a fraction. So once a P2 get the CPU, it executes itself completely. So according to chart, the waiting time for P2 is 40. Okay. For P3, this is 150 here. And before P3 occurs anywhere? No. So according to chart, the waiting time for P3 is 150. But this waiting time will correct if all the process comes at a zero time. So again, B minus arrival time of these particular processes in this waiting time. So arrival time of P1 is 0. So this will be 0 equals to 50. And for P2, this will be 40 minus arrival time of P2. What is arrival time of P2? This is 40. So 40 minus 40 equals to 0. And arrival time of P3 is 50. So this will be 150 minus 50 equals to 100. These are the individual waiting time for P1, P2, P3. If we want to calculate TAT, then we have to add their burst time with the waiting time. So P1 TAT will be 50 plus. What is the burst time of P1? This is 100. So 150. For P2, this is 0 plus 50 equals to 50. For P3, this will be 100 plus 60 equals to 160. If we talk about average waiting time, then add all the individual waiting time of processes and divide number of processes. And for TAT, same, 80, sorry. Summation of all the individual TAT divided by number of processes. This is the first method. Now we will see another method to calculate the waiting time and TAT. So in this scene, we can see here 5 processes with their arrival time and a burst time. So let us see what will be the waiting time and turnaround time for these processes. So here we can check the CPU will start execution with P4 because at the zero time there is only one process P4 and after that other processes. So this is the Gantt chart for above numerical. So P4 get executed for 1 unit time and CPU will check the ready queue on the regular interval time. On regular time interval, if there is any another process which want to get execute, and then it compare the bus time of all the available processes and the process which have the least bus time will faced by the CPU for the execution. So this is the Gantt chart. Up now with this Gantt chart, we will calculate average waiting time and turnaround time. So here is the second method using exit time. So from the Gantt chart, we note down the exit time for P1. You can see here P1 for 4 and for P2, this is 6. So P1, 4 and P2 is 6. Okay, don't get confused. P2 runs here also. So this is not the exit time. Exit time when P2 complete its execution. So P2 terminate here. So this is the exit time for people. So we noted down the exit time for all the processes like this. And for TAT, it's very easy. TAT equals to exit time minus arrival time of that particular process. So we calculate the TAT for individual process and waiting time. Waiting time is TAT minus burst time of that particular process. So here are the waiting time for individual process. Now, if we want to calculate average turnaround time, this is very easy. We have to add all the individual TAT and divide by total number of processes, and for average waiting time, add all the individual waiting time and divide by number of processes. In this manner, we will get average turnaround time and average waiting time for this system, for this scene. Okay. I hope this lecture will help you. Thank you for being with me. Thanks again. Here are some references which I have used in my lecture. Thanks a lot.